Okay, so today we're still talking about the quadratic formula and quadratic equations, but we're going to begin to apply this formula to real life problems. Okay, so in order to do this, anytime you have a real life problem or a word problem, we want to be able to represent that problem as an equation. Okay, by representing it as an equation, we can solve. Okay, we can solve for whatever we're looking for. Okay. So here we have a word problem or a real life problem. We have a problem that states the juggler tosses the ball into the air again. This time it leaves the juggler's hand 3 feet above the ground and has an initial velocity of 20 feet per second. The juggler catches the ball when it falls back to a height of 4 feet. How long is the ball in the air? Okay, so given this problem, what are we looking for? Okay, we're looking for how long the ball is in the air. What is that exactly? Seconds, so time. Okay, so we're looking for the time that the ball is in the air. Okay, so time is going to be the variable that we don't know in our equation. Normally it's x, but in this case it's going to be t. Okay, so whatever our variable is, that's the answer that we're looking for. That's what we do not know. Right? So what we have to do is we have to represent this problem as an equation. We have to come up with the equation that will give us our answer. So whenever we have a problem like this, when we have a problem where an object is thrown, okay, an object is thrown in the air, there is a specific equation that mathematicians and physicists have came up with, a generic equation that gives you a pretty good estimate. Okay, that gives you a pretty good answer to how long that object will be in the air. Okay, and that equation that you use is, okay, it is the function h equals -16t squared plus the initial velocity times t plus the initial height. Okay, so what we have here is the function that we will use whenever we have an object being tossed into the air. Alright, this velocity here, this v subscript 0, okay, this is the initial velocity. Anytime we have a variable or coefficient and has a subscript of 0, that usually tells us that it's the initial value, okay, the starting point. Okay, we also have a 0 here with the height. So this here is the initial height. Okay, we already know t is time, h stands for height. The value here is the height that we're looking for. Okay, this is the height, whether it's the end, whether it's where the ball lands, or whether this is the height that we want to know. Okay, so if we wanted to see when a ball reaches 20 feet in the air, you know, how many seconds does it take for a ball to reach 20 feet? This is what the h represents. Okay, the value or the height that we're looking for. Alright, now understanding this, we also have to be able to determine what kind of I guess trajectory that we're getting, and the velocity will tell us that. Okay, if the velocity, the initial velocity is greater than 0, then that means the ball's being thrown up or tossed up. Okay, the velocity is less than 0, it's being tossed down. And if the velocity, the initial velocity, is equal to 0, then it's parallel. Okay, So, having this equation, knowing that this is the equation that we're going to use, we can now begin to represent that equation for this specific problem. Okay, so looking at this specific problem, and anytime we have a word problem in that sense, the first thing that we want to do is find the important information. Okay, because there's a lot of words in there. All right, we just want to know what's important. So from looking at, what should we underline in this word problem? What should we underline? Okay, 20 feet per second. What else? 3 feet above ground. What else? One more thing. Yeah, so the height of 4 feet. Okay, so basically in this problem it's the numerical values. Okay, the numerical values are what we need to know. Alright, and now understanding that it's always a good idea, okay, when you have a problem like this, it's always a good idea to represent this by a picture, okay, or a diagram, or some just visual that gives us an idea or gives us more clarity to what we need to do to solve this problem. Okay, you don't always have to do it, but I recommend taking that step, especially once you first start working these problems. Okay, so what I'm going to do is I'm going to draw a hand, okay, little cartoon hand. Alright, and this is the start. Okay, this is the start. Alright, what piece that we underline goes with the start? Three feet above the ground. Okay, when the ball's in his hand before he throws it, it's at 3 feet above the ground. Okay, so here is 3 feet. Okay, I'll draw the ground as well. Sorry, 3 feet. Alright, now the other thing that we can draw is where it ends, because he catches it, right? So the end. Okay, and what will go with the end? Okay, what piece here goes with the 4 feet? Okay, where he catches it. So now what are we missing? Yeah, the velocity, okay? And we know if we throw a ball, it's going to go up, and it's going to come back down. Okay? If you throw a ball, it's going to go up, and it's going to come back down. Okay? And the initial velocity, that's the velocity when it leaves his hand. So we can write 20 feet per second. Okay? So let me ask you this. After drawing this picture, okay, I know some of you guys may have never thrown a ball before. So y'all may or probably did not know what it looks like. Okay, well that's what it looks like when the ball goes in the air. Okay, for you guys that didn't know, I just want to make sure. Alright, so if this right here was on a graph, what would we call that? Okay, a parabola. Okay, you can call it a parabola. Well, actually don't do that. That'd be incorrect. But it's a parabola. I know what you meant. So, we know that parabolas go with what type of functions? Quadratics. Okay? So, does it make sense then that the equation that we said we're going to use is a quadratic equation? Okay? Because this is a parabola, this parabola represents what is happening in this problem. So now we're going to use this quadratic equation, okay? We're going to use this and we're going to begin to fill in what we know, alright? What we know. So this The generic equation becomes specific to this problem. Alright. So now, so what we're trying to find is t. We want to plug in everything that we know. So if we start with the start, what is that value? Where can we plug in this 3 feet? If this is the start, okay, where can we plug in the 3 feet? Yeah, the 8 sub 0, okay. This is the initial height, so initial means start, okay. That's why I put start here, so we can make that connection. Okay, so here goes the 3. Alright. Now, what about this velocity here? Where does that go? Okay, the v. So that is now 20t. Okay, we don't know t, so t stays there. Okay, this first term, there's nothing there that we can plug in because we still don't know t, so that stays the same. And someone in the earlier classes are like, well, we'll always be negative 16t squared. The answer is yes. One, we have this type of problem. When we have a problem where an object is being tossed in the air, okay, or when an object is being dropped. Okay, so now this height here, the height that we're looking for, is 4, okay, because that's where he catches the ball. That's the ending height. That's the height that we want to know that is dependent on the amount of time. Okay, so now we have everything but the t, so we can solve for t. Okay, we can solve this quadratic equation. Alright, so my question is, how should we solve this? How should we solve this? If you don't have an idea, you can look at the board, the lesson plan. The title of the lesson plan. Yes, okay. The quadratic formula, okay. So what do we know about the quadratic formula? Can we use that right now? No, what do we have to do? Yes. You have to set this equal to 0, okay. Once it's in standard form and set equal to 0, we can then use the quadratic formula. Okay, and 3 minus 4 is negative 1. Right, so we now have this equation. Okay, so what is my A? Negative 16, my B, 20, and C, negative 1. Gotta subtract the 4 from, okay, so now this is what we're going to plug into x equals negative b plus or minus square root, yada 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 yada. Okay, so what's opposite b? Negative 20, okay, plus or minus the square root of b squared, so 20 squared, minus 4 times negative 16 times negative 1. Okay, and that is all divided by 2 times negative 16. Okay, so now, now the first part we want to find is this discriminant. Okay, that's the first part that we want to solve. Okay, so go ahead and get your calculator and find out what number is under the radical. Okay, what is this? Simplify to. What's the 2 times negative 16? Negative 32. Okay. So, what's 20 squared? 400. Okay. So, what's 4 times negative 16 times negative 1? 64. Okay. So, we have 400 minus 64. Okay. What does that come out to be? Okay, so we get negative 20 plus or minus the square root 336 all over negative 32. So we get this here. Alright, now this is a real life problem, okay, a real world problem. We're not just speaking in, mathematical terms. We want to know what this represents. Because if you guys, okay, let's just pretend here, this little orange, okay, this little styrofoam orange that I've showed you guys or used before. Do you guys remember this orange? The fake orange? Okay, well, let's just pretend there was a real orange, okay? You brought a real orange to class, and you were mad at me. So you threw it at my face. Okay? We're just pretending here. Alright? And after you threw that at my face, you're like, Mr. Johnson, how long did that take to hit your face? And let's just pretend I was just like really chill that day. And I was like, that's a good question. Okay, let's figure this out mathematically. Alright? And then I told you that it took negative 20 plus or minus the square root of 336 divided by negative 2 seconds to hit my face. Okay, 1, I'm being sarcastic back to you because I'm probably mad. But 2, that doesn't make any sense to you. You don't know what that time is. Okay, so unless you're, Albert Einstein. But I'm not that, and I don't know if you guys are that yet. Not yet, at least. So what you want to do is we actually want to find the decimal form of this answer. Okay, we want to find an estimate. Okay, anytime we have decimals, we're not going to write 1.45682578234. Okay, we don't have to do that. We can just give an estimate here. Okay, so the way you write that, when you get your answers, I'm going to write that over here. You'll get T, and then this symbol here means approximately. Alright, we still get 2 answers because it's a quadratic. So I want you guys to do, okay, is find out what this represents. Okay, when you do that, when you plug into your calculator, find out what the top is, the numerator, and then divide. Okay, so do negative 20 plus the square root of 336, hit enter, and then divide by negative 32. Then do the same thing by subtracting the square root. Okay, and let me know what you get. Guys, figure it out. At least one of them. What did you get? Yeah. Okay. Yeah, so one of them, it was like 0.05 something. Okay, so we'll round that to 0.05. Okay, so 0.05 seconds. What about the second one? Okay, 1.2. We'll round that one to 1.2. Okay, so both of these say time is approximately 0.05 seconds. Time is approximately 1.2 seconds. Okay, now let's use that same scenario. You throw the orange at my face. I decide not to get mad and consider your question. But this time, I tell you that the ball is in the air for 0.05 seconds and 1.2 seconds. Now you're still looking at me like I'm crazy, okay? Can a ball or an orange be in the air for 2 different times at the same time? No, not that we know of. Okay, and if you know that it is, then you will probably be famous by making a theory. But anyways, that is not possible. Okay, so that means is we should only have how many answers? 1. The ball can only be in the air for 1 amount of time. Okay, so what we have to do is we have to use our logical thinking, okay, or critical thinking skills, and decide which of these values is the correct value. Alright, so if you guys want to look back here, if I was juggling, okay, I don't want to take all this stuff. If I was juggling and I am in the motion of juggling, right? If I go like this, is the ball going to do that? If I'm like this, is it going to do that? Okay, no, that would be really weird. We'd like be on Jupiter or something. Okay, so that's what like 0.05 seconds would be. As soon as it leaves my hand, it comes back down. Okay, you think about someone juggling, throwing the ball 20 feet per second. That's not what happens unless you're juggling with bowling balls. Okay, so if you think about 1-2 seconds, that's like. Okay, so let me ask you, having think about those 2 scenarios, which one is going to be your answer? 1.2. Okay, so that's our answer. Because this problem, although it doesn't say, we're talking about Earth here. Alright, so 0.05 seconds, that's unrealistic. So we can toss this one in the trash. Okay. In the trash it goes. Okay. So having understood this, sometimes your answer will be negative. It'll be easier to decide which one's real and which one's not the right solution. Okay, because if it's negative, can you have a negative time? No, not that we know of. Okay, so again, whatever your answer use your logical thinking and critical thinking skills and determine what value represents what you have here, the problem that you have. Okay, this is what you guys are doing today. Alright, I made the lesson a little bit shorter so that you guys would have time to work some of these. Alright, the biggest thing is just being able to come up with the equation that represents the word problem that you have. Today, all your word problems are going to be ones in which the object is being tossed in the air, so you'll always use this generic form here and then apply the information you know to the general form. Alright, I did assign one problem where I didn't cover in class, and that's because I want you guys to use your prior knowledge to figure it out. Okay, I want you guys to at least try it, even if it might not make sense. Try to apply what you know to that problem. Alright, there are 4 homework problems, but I'm counting it as 7. Alright, there's one problem with 3 parts and another with 2. So to help you guys out, I'm going to count it as more. That way you have more opportunities to get the right answer. Alright, if you choose to not do it, that's going to hurt you more instead of helping you. Alright, you guys have a good day.